Um, and so when the detectors are actually operational, so we just came out of an upgrade, and so right now the detectors are so at Hanford they just closed up the vacuum system last week, and they started pumping down, removing the air from the corner station. At Livingston, they so after about 1 year of an upgrade, they started pumping down 2 weeks ago, or maybe the week, yeah, 2 weeks ago. And so now they started to realign all of the optics, sending the laser in, making sure that, again, testing that everything is working. So they have locked their first cavities last Friday, which is very exciting. And so probably there's going to be 2 or 3 months of commissioning time when the detectors are going to be tuning the detector, making sure that everything is operational. And then in September, we'll start a new observing run we call IR1. And that's going to last for about 6 months. And then we'll go back and then do another series of upgrades. So from when the detectors are operational, from here we can see the status of the detector. Usually you'd see, on those screens. So the top row would be the Hanford detector, and then bottom row would be the Livingston. That's why some of the screens look similar. But you would see how much power is going inside the arms. You would see the status of the various suspension or seismic systems. You'd see how much watt is circulating inside the arms, and then in best case scenario, all the screen, all of the status screens are green and all good and we're operational and just listening for the. But while we're doing this, we have to always. What happens is that this is a good time, exciting time to be in observing mode. But what we do is that we are always thinking about designing at the next phase. So usually, quiet time at the site means busy time here because we're in full design mode. This screen here it shows the state of the vacuum system for Hanford. Someone was asking me about how to keep the different volumes separated. So all of those lines that you see, you know, here and here and here and here, those corresponds to gate valves to separate the various volumes. And then we have, all of those numbers here are gauges that tell us the pressure at each point in the interferometer, both along the arm and then at the end and in the corner station. And so for Hanford, because they just started pumping down this volume, you can see those gate valves are red, so that means that they're closed. And so once the corner volume reaches a pressure that's low enough, they can open the gate valves, and then they can shine the beam on the long tube. Um, so yeah, this room for us is used also for it's as a kind of a training facility for students so that they get used to the tools that um, the detector is using. And so when they come here, we also from this room we can interface the experiments that we have in the other labs. So if we need quiet time and we can't be in the lab itself, then we can come in this room and then do our data analysis from experiments that are in the other labs. And because it's all the same, all the same tools to acquire data and then to plot spectrum when they go to the site, when students go to the site and they're trained for that. So this is where, and then we also use it as a conference room. And then in the in the back, you can see that's a nice plot to end. Those are all of the binary systems that Ligo has detected so far. Um, it's plotted in this interesting shape that has no particular meaning apart from the fact that it's a nice shape. But what this means, maybe Gabriele already showed this one, or so you can see in the vertical axis, um, those are they always have 3 points, and so the 2 points would be the two black holes, for instance, their weight, and then the weight after they collide. And so
Yeah,
this is
he showed the picture, but
solar masses.
but yeah,
And then
cool.
And then those ones, those are the orange ones are neutron star. And so this one, for instance, it's a neutron star that merged with the black hole that made a black hole of about 7 solar masses. And we also have maybe the neutron star that made something that's in between. I don't know what. I think when it's in this range, it's we assume that it's a neutron star, but there is a zone in which it's hard to define if it's a black hole or a neutron star.
And I think that the mass difference, so you would expect, I don't know, it's 18 plus 40, so you would expect 58, right? But it's not actually quite that, and then the mass difference is what is lost in gravitational waves.
Mhm.
That's the energy that we can see.
I think that's all I had for this room. What else was there? Yeah, but I'd be happy to take any questions and take as much time as you want to take pictures. Or